Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for January 5th, Thursday, 2012. We're going to get right into it because I promised to keep the videos under 15 minutes. Today we're going to be looking at systematic word problems, actually story problems that have a system hidden in them. If you can find the system, it's really easy because then you can use graphing or substitution or elimination to go ahead and solve. So let's take a look at our first problem here. Let me see. There it is. Oh, age problems. You guys remember these? These are not bad, guys. They're not bad. Let's take it step by step. Yeah, you didn't realize way back in the first quarter you were doing systems there, did you? Okay, today Stan's age is 2 more than 4 times Betty's age. Well, let's see. I know I'm going to need a couple of variables here. And I'm going to say, first of all, let S equal Stan's age. That's the age today, of course. All right. And then I'm going to make B equal Betty's age. Right? Okay. Now, today, Stan is 2 more than 4 times Betty's age. So to find Stan's age, I need 2 more than 4 times Betty's age. There we go. There's our first equation. See how easy that was? I need Stan, to find out Stan's age, I need Betty's age times 4 plus 2 because it says 2 more than 4 times Betty. All right, now if I could find a second equation, I could use my systems and solve. So let's see here. Let me scroll back up a second. 5 years from now. How old is Stan in 5 years? Well, if today he's S, then in 5 years he must be S plus 5. How old's Betty in 5 years? Well, if she's B today, in 5 years she'll be B plus 5. In 5 years, 5 years from now, Stan will be 1 less than twice her age. Well, I know I'm going to have to subtract 1, but I got to be careful. What's her age in 5 years? It's B plus 5. Well, I need 1 less, not than B plus 5, but then twice B plus 5. And now that I have the 2 equations, I can go ahead. I think I'll use substitution on this one. This would be the easiest way to do it. And I will take this 4b plus 2 and I'll plug it in for S in the second equation. So when I do that, I'll get 4b plus 2 plus 5 equal to, forgot my equals there, sorry, distribute 2b plus 10 minus 1. I'll combine like terms on both sides. And then I will subtract 2b from each side. End up with 2b plus 7 equals 9. Therefore, 2b equal 2 and b will equal 1. So Betty's age today must be 1 year old. Well, now it's easy to figure out Stan's age. I'll take that 1 and I'll plug it into this equation right here. So that will equal 4 times 1 plus 2. Therefore, Stan must be 6 years old today. So Betty is 1. Stan is 6. And I'm done. Okay, now you have to take it slow and look through the meaning. All right, let me see. How's the time on that? Good, about 4 minutes. That's not too bad. Okay, let's look at a different type of story problem. All right, Matt has a pocket full of quarters and dimes. Altogether, he has 24 coins. If he has a total of $4.05, how many quarters does Matt have? How many dimes does he have? To do this problem, I'm going to make a table. Let's see if I can.
Jacob?
Okay, so Matt has a pocket full of quarters and dimes. Altogether, he has 24 coins. If he has a total of $4.05, how many quarters does Matt have? How many dimes does he have? I think I just read that, but couldn't remember if I had or not before that announcement came. First thing I'm going to do is I'm going to make a table. Okay, and I'm going to have, oh, don't use the black marker, Mr. Lawrence. Okay, my table is going to look like this. First, I'm going to have the number of coins. Okay, and then I'm going to have their value. Then I'm going to have the actual money. Now I know I'm dealing with dimes and quarters, and then I'm going to be dealing with the total amounts. This table can really make it easy to figure out where my two equations are hidden. Okay, we know the story says he has 24 total coins. So I'll put the 24 there. We know that the coins are made up of dimes and quarters. How many dimes does he have? I'll bet Haley doesn't know. And it's right. And she knows then to put a D in for the number of dimes. The quarters. I'll bet Lauren doesn't know how many quarters there are. So therefore she'll put a Q in the quarters place. Believe it or not, we have our first equation. We have that D, the number of dimes, plus Q, the number of quarters, must equal 24 coins. There's our first equation. See how simple that is? Now this value thing, it's not going to give us an equation, but it's going to help us get an equation. We know that dimes are worth 10 cents. We know that quarters are worth 25 cents, right? We know that the total amount of, well, I'm not going to fit it in the total there yet. I'll do it soon. All right. The money. The money from the dimes can be found by multiplying down. 10 cents for every dime. The money for the quarters can be found by multiplying down. 25 cents for every quarter. The total amount of money we're told is $4.05. We have our second equation. Do you see it? It's 0.10 D plus 0.25 Q. That'll equal $4.05. There's our two equations. There's our system. We can use this system, solve it using either substitution or elimination, and then go ahead and figure out how many dimes and quarters they have. So let's go ahead and do this one by elimination. I like substitution better, but I know some of you like elimination better. The first thing I'm going to do is I'm going to multiply this top equation by a negative 0.10. So I'm going to multiply by negative 1/10, and I'll multiply here by a negative 1/10, and then here by a negative 1/10. I really would have preferred to have done this problem using substitution, but that's okay. I don't mind doing it for you. All right, so I'm going to rewrite the blue equation, and maybe I'll just copy and paste the red equation. There we go. All right, so the blue equation turns out to be negative 1/10 D minus 1/10 Q, and that'll equal negative, oops, negative 2.40. Why did I add the 0 on the end? Because I'm thinking about money. I'm thinking about $2.40. Okay? All right, so here we know those will cancel, right? If I combine these two, I'll get 0.15 Q. And over here, let me see here. I know that $4 minus $2 will be $2. But I have to take another 40 cents away, so I'd be down to $1.60. But it wasn't $4 to begin with. It was $4.05. So I believe this will come out to be $1.65, or 1 65 hundredths. Now I can simply divide by 0.15, and then I will know the number of quarters. And we can go ahead and use our calculator to find that the number of quarters is 11. That's pretty cool, I think. Now, to figure out the number of dimes, that's easy. I know that D plus Q equals 24. Well, if Q is 11, then D must equal 13. So the number of dimes is 13, and the number of quarters is 11. So dimes 13, number of quarters equals 11. All right, let's get on to the next problem. Dr. Honeydew, sorry about that. I don't know if I'm repeating myself, but I'm going to read it again. Somebody came to empty my garbage. Dr. Honeydew needs 60 milliliters of a solution that is 38% acid. He has 2 bottles of acid, one that is 22% acid and one that is 43% acid. How many milliliters from each bottle must he mix together so that he can create a 60 milliliter solution of 38% acid? So what's going on here? He's got 2 bottles. He's going to take a little bit of the one from the 22%, and he's going to take a little bit of one from the 43%. And he's going to average them together to get 38. Now, I mean, if he averaged exactly, like he used the same exact amount from the bottle of 22% on the bottle of 43%, well, what percentage would that acid be? Well, I could average 43 and 22 and get 65 divided by 2, and 66 divided by 2 is 33, so that would be 32.5%. Okay, that's if you use the same exact amount of solution from each bottle. Okay, but he doesn't want a 32.5% solution. He wants a 38% acid solution. So that's not going to work. The problem's a little more complicated than that. Actually, if you use a chart or a table, just like we did on the last problem, it's not that bad. Hold on one second. Okay, to set this one up, my table, first thing I'm going to need the 28% acid solution, the 43% acid solution, and the total. And over here, I'm going to need the milliliters of each solution. I'm going to need to know the percent as a decimal, and then I'll get the amount of acid in milliliters. Not the percentage of the acid, the amount of the acid. All right, so how many milliliters of the 28% solution is he going to use? We don't know. How many milliliters of the 43% solution? We don't know. How many total milliliters does he need? Oh, 60. There's our first equation. X plus Y equals 60. All right. The percent as a decimal, 28% as a decimal, 0.28. Hey, that kind of looks like what we did with the quarter and dime. We put a decimal there, didn't we? All right, 43% would be 0.43. I'm not going to put anything in there. Now, to get the amount of acid in the solution, I'll multiply 0.28x. I'll multiply 0.43 y. Now, I can't just put actually in this total I do want something, excuse me. The total amount of acid, I want it to be 0.38. Okay, sorry about that. Now, to get the total amount of acid, I'll need to take 60, oops, excuse me, let me be consistent, 0.38 times 60. There's my second equation. My second equation will be this. 0.28x plus 0.43y. That'll need to equal 0.38 times 60. All right, I'll do a quick simplification here. 0.38, 3800 times 60. Whoa, what am I doing? That ends up being 22 and 8/10. Okay, so now I'm going to go ahead and use substitution. It doesn't matter which one I solve for, so I'll solve for x. X is going to equal 60 minus y. I'll take this and plug it in there. So, no, I won't. Scratch that. I will plug it in there. Pardon me. Going a little bit fast here. 0.28 times 60 minus y plus 0.43y, and that'll have to equal 22 and 8/10. Okay, so I'm going to multiply 0.28 times 60. I'll get 16 and 8/10 minus 0.28y plus 0.43y equals 22 and 8/10. I simplify it by combining the like terms, and now it's just a two-step equation. And so from there, I will solve it. Gotta stay in right mode, minus 16.8. Y will equal, looks like it's 6 on the nose. That's just a coincidence. I'll divide by 0.15. Y will end up equaling 40. So we'll need 40 milliliters of the 43% solution. If you need 60 milliliters total, remember that x plus y has to equal 60. Therefore, x plus 40 must equal 60. Therefore, x must equal 20. So then x will equal the 20 milliliters of the 23% solution. No, 28, excuse me. And there's your two answers. It won't always work out that pretty, but in this case it did. All right, sorry I went over the 15-minute limit that I'm trying to stick to. The word problems are a little bit longer, and I do need to explain them. Okay, tomorrow we'll get some more practice with this kind of stuff in class. Mr. Lawrence signing off.